Hey everybody, welcome to the only cloud engineering project that you need to do to get a cloud engineering role job. So in case you don't know me, I'm the founder of CodeGenitor, and I've also built my own SaaS application end to end, and I'm going to show you how to build a production grade SaaS application end to end. So without further much ado, let's jump right into the tasks that we need to do today. So we are going to create a project from ground up. You are going to do this with me from zero to end. Okay. So without further much ado, I will open my VS Code. Hopefully you can see my screen now. Yes, so I'll open my VS Code and then I'll create my project folder. So you can do the same. You can create a project folder. I have one in here, tutorial. So yes, so I have one with the name is going to be DevOps. So this project that we are going to create is going to be DevOps, meaning developer experience. You understand? So whenever you are trying to build an end-to-end application, you need to ensure that you have developer experience in mind. Okay, you have to build it. I come from a development background, so every structure or every system that I try to build, I try to imagine myself as the customer. You have to be the first customer of your product and then try to make it better for the developers as well. Okay, so developers and clients, everybody will be happy. Now, so before we do anything, what I like to do is to have a to-do file. So to-do main to-do tasks .md, so that we can just rough sketch. So now we need to build a system. We are thinking in this way. We need to build a full stack system. So what is a full stack system? Well, a full stack is an application that is going to consist of the front end and the back end. So don't overthink it. I'm not going to overcomplicate any concept here for you. I'm just going to give you the real deal. Sorry about that. So a full stack application is just client side and backend. That's all. That's all you need to know. And in this day and age, you need to master both the client side, the back end, and then the DevOps as well if you want to really stand out as an engineer. Okay? So we will build client side, build backend side, connect backend to client, package them into Docker containers. So now, but before we do all this is going to be the local side. So now, before we do all this, we need to think about where are we going to host our application. So this is where the infrastructure comes in. This is where a cloud engineering expertise comes in. Okay, so you need to be a very good architect in cloud engineering role, and we are going to use AWS. We will use Kubernetes. So we would be using all the latest technologies that every job requires you to know how to work with them. Okay, so we will configure infrastructure infra on AWS. You can use Azure, you can use GCP, anything you want. Okay, don't stress. We also need to use Kubernetes, so KDS. Yes. So without further much ado, think now that we have an outline, we need to see how we can do this. Okay, and again, we are going to have GitOps in this project. So this is going to be the ultimate guide that you need to actually nail any cloud engineering role or platform engineering role that you will be facing if you are going into one. And then also, if you are trying to also build your own SaaS application, then I think this is all you need to learn and practice to do your own SaaS business as well. Okay, So now these days you don't have to think about the code. The code is just the least part of it, but the architecture is the main aspect. Okay, you need to learn how to work with AI, and then you have to be fast. Everybody is being fast, so you have to also be fast. I remember I used to feel like using AI is like giving my power away, but one thing I've got to learn and understand is I built faster with it, and it hasn't taken actually anything from me. It's just the same tasks that I've been doing that are repetitive, that is being handled by AI, and it makes my work very faster. Okay, you can use Claude. Me, I use Codex. So I use Codex because I have ChatGPT Premium. So you can use Claude if you have Claude access. So let's see what we will do. So first of all, before we create anything, we go into our GitHub. If you don't know GitHub, then you have to go and learn about GitHub. Okay, so first of all, we go into GitHub and try to create a repository, because now when you are going to build your application, where are you going to keep your code base? You need to know where you are going to keep your code base. Okay, so you need to use GitHub. You can use GitLab as well. So when you come to GitHub, we can create a fresh project. So create a repository, and then this one we are going to call it DevX. Okay, DevX. Nice one. Give it any description that you want. I don't think I will give a description. Here is going to be a public repo, so everybody can see this. Yes, and the next thing is just to create. Okay, choose the owner. Choose myself, not my company. So yeah, so you create a repository. Now we are done. So let's push our first code to GitHub. Let's push our first code to GitHub because we have a README file. So let's push it there. Okay. Why my system is very slow today. I need to put some power on. Okay, so I'm back. I hope it works fast. So git init. So first command git init. Now we've initialized, and then git commit. So when you initialize, we commit. Okay. No, we add first. Git add everything, and then we will commit git commit -m, and then you say initial setup for DevX. Okay, now we need to push it. So create a branch. We will create the branch. Oh, I forgot to minimize my screen so you couldn't see. Yeah, so if you don't know how to create a GitHub repository, if you just come here, click here, create, and then new repository, and then just follow the prompt along. Okay, that's all we did. Now we need to create the branch. So I will create my branch. Oh, not that project. To do tax. Yeah. Git branch -main. You know what? Let's call this master. Okay. This is the master branch. Now we have our master branch. So this is good. And then now we can connect. We can connect to the remote repository. So git remote add origin and then the URL. Okay, just the same command that git will give you in the browser. Okay, so it's just this ones that I just copied. Okay, and then the last thing is just to push it. Okay, so we'll go back to our code. So git push origin is master because we don't have main. Master Then now we can push our code to GitHub. Nice one. So congratulations for pushing your first code to GitHub if you have not done it before. This is your first GitHub. Then you have successfully deployed your code to GitHub. This is good. So we need the to-do tags.md. Yes, it is here. Now we can see we have our to-do tags.md here. That is good. That's all we needed. Okay. So the next thing we need to do is ensure that we have both our client side and then our back-end application. So we can begin to test locally as well. But before that, we are going to deploy the system on AWS. So now we need the infrastructure. It's like building a house. Our application is the house. But then for every house to come to life, you need a foundation. If you get the foundation wrong, you can't build sand castles. Okay, so if the foundation is wrong, you are going to collapse your house. Okay, so ensure that the foundation is strong, and that's what I'm going to give you. I'm going to show you how to make the foundation stronger, build a very solid platform that you can rely on. Okay, you can also scale it. It is going to be scalable. That is one key factor you need to put in mind. Whenever you are building a system, you have to think about how can you scale? How can you scale? Can it handle more users? You need to think this way, okay? It will help you in the long run. So we will start with the infrastructure. So we would go to infrastructure, go to the code, and then because we are in the master branch, we are not going to do anything in the master branch. I'm going to show you how I like to build my systems, okay? And how you can also build your system in the same manner so that you can work on your system and then you can invite people to work on your system. Let's say, for instance, you grow and then you want new teammates to join your team. Not everybody should have the permission to just deploy the code to the master branch. Because if you deploy the code to the master branch and then it goes live to production, you can end up not having a very good customer experience. So you need to ensure that senior developers are only going to be allowed to merge code into the master branch. So let's treat ourselves as a developer. So we would create another branch. Now we need another branch called staging, and then we need another branch called development. So in creating a solid system, now you need one branch called dev, where you also have a development area where you can build features, deploy it into the dev, and then check your features in the dev environment. Okay, and then now when it passes from the dev environment, now you need to merge it into the staging. Now in the staging, this is where you think about it like, oh, in this staging environment, it's semi-like a production environment, but just a staging environment, okay? It is just like a semi-production environment, but we are going to treat it as a staging environment, okay? So if everything goes right in staging, then we are rest assured that production will be okay. So, sorry. The next thing, create a branch. So git branch -b. So git branch -b. We can use git branch -b, but I'll git checkout -b, git checkout -b, and then I'll say dev. So dev branch. Now we are in dev branch. So git branch. Nice. So remember, whenever you create a git branch, now we did create it from the master branch. So everything in the master branch is going to be in the dev branch. So that's how git works. Okay. When you create from a branch, whatever it's in that branch is going to be in the same branch. So that's what we needed. We are done. I'll clear the screen. Now we will create another one. So git checkout -b staging. Now we also have the staging branch. Nice one. So git add git commit -m, and then you say initial staging branch. Nice one. Nothing to commit yet. Yes, so I will just add a hash here and then say staging. You say staging. That's it. Git add git commit -m initial staging branch, and then git push the code. Okay, so we need to set the origin. So git push -- set upstream origin staging. That's it. Run the code, and then we will clear the screen. Now we need to switch back to the dev branch and do the same. Git checkout clear the screen so you can see. Let me clear the screen so you can see. So git checkout dev. When you write D, then you can just use that the tab, and then you will switch to dev. Okay, so now we have switched to dev. Nice. So here we can also say dev. Okay, and then git add git commit -m initial dev branch. Nice one. So once we have done that, then we can also push this one to GitHub. So remote. God damn it. Let me clear the screen. Git push. Just run git push. It will give you the command, but normally you can just run git origin, and then you give the origin name. Git push origin, and then the origin name. You don't even need the upstream. Let me show you how it works. Git push -u, and then the origin name. That's all. Then you can just push it to the dev branch as well. So now let's go to GitHub and then see what has happened. So boom, good job. So now we can see we have 3 branches. Very good. We have one for dev and one for staging. And again, remember, dev is going to be where when we push code from our local computer into dev branch. Remember, whenever you go in an interview, somebody can ask you, what is the difference between the dev and then the local branch? You have to know that local is when you are building on your computer, okay? And then when you push from your local branch, you don't push to master branch. You need to push to dev branch. It needs to be a hierarchy. You know, you might want to be smart and push dev to master branch. And if your engineers have not restrict access to new developers or junior developers not to push code into the master branch, imagine the mess you are going to have. Okay, so now we will push to the dev branch. So we have code in the dev branch. So let's go to dev branch. Now you see the readme. We have dev here, which is good. So dev code is different from staging branch. So go to staging branch and then check the code here. You see we have staging here, which means it is different code that we have. Now let's go to master and check what we do have. We see we don't have anything here, so this is good. This is separation of concern. You understand? This is called separation of concern. So we will go back and then we will see what we can do. So the next task that I don't know why I keep showing my SaaS application system. Yeah, not to flex my muscles, but it's just I keep going back there. Yeah. So this is what we have now. Now the next thing we are going to do is to build the infrastructure. When we build the infrastructure, then we can also look at then deploying our application, which is going to be very fun. Okay. I love to do this stuff, so hopefully I will be able to share some light into your life, and then this will be also easier for you. So now I'll go to AWS, so console, remember, so console, and then I'll go to AWS. I have to find my credentials so that I can log into my account. So give me a second, let me find my credentials. Okay, so now I've got my credentials, so now I can log in into my AWS account. So code janitor there, and then I will get a password. Okay, now I will sign into my account. You can do the same. So if you don't have AWS account, I would recommend, let's go back so I can show you. So if you don't have AWS account, you just come here and then click on create account. When you click on create account, then you can follow the sequence to sign up. It will require you to have a credit card to verify your billing. Okay, so I would go back and then I will log in, sign into existing AWS account. Now I should find my credentials again, get this one, put it there, and then I'll get my account ID. Oh, password fails. Okay, so nice. So now that we've logged in, whenever you create an AWS account, you are just going to be in your root account. You should not do anything in your root account. Okay, that is where you manage your AWS organization and stuff. Okay, so we will go to I am user, so something called I am user, identity and access management. That's what it means. Okay, if you're also going to sit your AWS exams, remember I am stands for identity and access management. Okay, so you can go to I am user and then go to users. So we need to create a user. You can create a user. Now when you create a user, give the user a name, tester, whatever the name that you want. Go to next, but before that, go back, provide console access. Select that one because that is what we need. We need the console access. We need the secret key and access key so that we can pragmatically communicate with our AWS resources without needing to come to the browser, because I'm going to show you two ways that we do this. Okay, the good way and the tedious way, not the bad way. I don't think there is anything that's bad about one way or the other, but there's one tedious and then there's one that is good. Okay, so we would go to next, and then you can add policy to it. So you can add a permission if you have permissions for the attach the user to a group policy, or copy an existing permission, and also you can attach policy directly. So now this is where everything happens. So when you are creating a user, let's say I am a new user that I want to work with you. You don't know me, so you can't go and give me administrator access. Administrator access, don't do that. Don't do that. Look at all the resources you want to create. If you want to create EC2 instance, in the permissions, in the attach policy directly, select EC2. EC2. You have AWS Elastic Container, whatever you are going to use. We are going to use all this Elastic Container Registry pool only. Remember to give least privileges. Okay, this is one core principle. Again, if you are going to set your AWS exams, another key code I'm giving you: least privilege. Everything that you do in cloud, think about giving least privilege. Okay, why do you have to give least privilege? If you over how do you put it, if you give permissions too much, you end up exposing your application. So if somebody got hacked, let's say you are working with me and then I've been a target for a nation state actor and then I've been hacked. Now, because I have an administrator access, they can have total control over your AWS resources, and there is nothing you can do, okay? And there's nothing you can do unless you have to close the account, which I don't think you can do when you have systems running. So yeah, so you give the permissions here, and then you just go to next and then create user. I have already created my user, so I won't do it. So when you create the user, then you will get the access key ID and then the secret ID. Please remember to save them or download that file and save it, guard it with your whole life, okay? So now, what I was talking about is when we need to deploy our application, we can one deploy it manually. So let's say we will need 2 web servers. So if you need 2 web servers, you go to the instances, EC2 instances, and then launch instance. Now you can create your first instance manually. Instance 1, select Amazon Linux or Ubuntu Linux. Get the instance type, so whichever instance type that you're going to use, get that one. Come down here, allow SSH, or if you don't want to allow SSH, you can define all these resources, and then you launch the instance. Imagine you need to deploy 50 instances for the company. Now you go into a company. Now they tell you, okay, Mr. Johnson, we need to deploy 250 instances. So how best do you think we can do it? And then we need to also do this at a scale. Now you'll be there. Okay, I have to deploy instance 1, instance 2, up to instance 50. My friend, you are joking. You need to, in this day and age, you have to learn how to deploy AWS resources pragmatically. Do it in a cloud formation way. Usually I use Terraform, but recently I've come to fall in love with cloud formation, which is the one I'm going to show you how to build your system using cloud formation. So you just build the infrastructure very fast. When you use cloud formation, or if you use Terraform or any infrastructure as code tool to provision your infrastructure, now you can be a crazy person and then say, you know what, today I don't want to serve any customers, so I want to tear down all my application. You can do that. You're allowed to do that. You just one command and then you destroy everything, okay? And then I'll be there. I'll also deploy my application and then I'll get all your customers, okay? So please don't do that. But you can just destroy it at a time, and then you can also spin it up at a time. So using CloudFormation or using an infrastructure as code tool, it is, yeah, if you don't know, it's difficult. You think, oh, I have to spin up a chunk of code. But friend, you do it one, you maintain it. Or you create 50 instances today, and tomorrow you come and create another 50 instances. Which one do you like? Just comment down there. Which one do you like? Because if you want the best aspect, you don't just look at the fancy aspect. It's beautiful UI. I can come and create a VPC, create a networking, create the security group. It's tedious, man. I'm going to show you the better way to do it, okay? So when you do this, then you can deploy your application. Now when you do this, now you need to come SSH into the web server. Now you need to maintain the web servers. Again, you need to do it manually. So now you have 50 instances, and then I tell you to deploy Kubernetes on all the 50 instances. We need to serve the customer, so we have 2 days of work time to finish this. Imagine the stress that you are going to be in with your colleagues, my friend. It's not fun. You need to learn how to scale. You need to learn how to be scalable yourself. Okay, me, I like to be scalable. So we'll just go into deploying all the stack on through infrastructure as code, which is going to be very fun for us. So again, when we get access to let me show you IAM user. When we get access to the IAM credentials, then we have to log in directly from our CLI so that we can begin by testing locally, and then I can also show you how we can do it hands-free. I'm going to show you how we are going to do it all hands-free. Just push the code to GitHub and just relax back. Just think about how do you scale, how do you scale, how do you scale. That's all you got to do. So security credentials, and then I have some security credentials here. Yes, then you can see the access key is here. So this is the one you need. When you go to the user, you click on create access key, then you can create one. So I have my access key here, but you can see my password. Okay, nice one. So that's what I'm going to use to manage all my AWS resources. So I'll go to the terminal. Let's go to the VS Code again. Now let's configure. So AWS configure, run AWS configure. Then we can, yes, we need the access key ID. We need access key ID. So I'll get mine. I'll paste it there. And then we need the secret key ID. Again, I'll copy mine and then I'll paste it there. But you see, don't share this because I will not show you my secret key. Do not share this. This is dangerous, okay? I will save it, and then the next thing, the region that we want to use. So the default region is US East 1. That's what we are going to use. You can decide to use any of the other regions, okay? US West 1 or Asia or Africa or anywhere that you want that AWS provide. Now the output format is going to be JSON. Yes, we love JSON. So yeah, now we are done. We are done. Nice one. Okay, so now that we are done, now we are going to begin by creating our resources. We are going to begin by creating our resources through infrastructure as code. So now we are going to begin to write some code, and then I'll be walking you through how to write some infrastructure code. And if you're able to do this, trust me, you should be able to talk about it in the interview. If you can do this, you don't have to panic. There is one thing about learning a theory. You know, when you follow a tutorial like this that I'm showing you and you don't practice, you can sit in the interview and then somebody will just ask you a practical stuff. But if you do it, you can see all the challenges. You are going to see all the challenges that we are going to face. I'm not going to really edit anything out of this video so much. So I want you to see how we build, how we think, and then how we bring the system to life, not just the fancy aspects. We are going to be in this together, okay? So let's move on to the next phase. Now in the next phase, we are going to start by deploying the infrastructure, because remember, when you are building a house, you need the foundation, and the infrastructure is going to be our foundation, okay? Because we need a place to live. Our application need a place to live, so we need to ensure that we are going to give it a proper home to live by giving it a proper infrastructure, okay? So before we begin with the infrastructure, I could see that I did not show you the browser. I forgot to minimize, so let's see if we can do a quick run there. So you can see how it works. I will minimize this one. Now when we go to AWS, so we should open AWS. So AWS, and then we have to sign in. So it's console. We gotta sign in again. So we must sign in again. I'll get my credentials and then I'll sign in now. So I need to look for my credentials. And then I can sign in now
Again, remember, do not share your credentials with anybody, okay? But if you want, you can share it with me if you want to be so nice, but don't do it, okay? So yes, now I've signed in again. You'll see what we can do here. So yes, so we need to create the IAM user. It's very important you create an IAM user in your account. So if you are in the root folder, if you just created an AWS account, you can just use that one, okay? Let me check if I'm recording this one. Yes, I am. So you go to IAM user, and then we can go to users, search for users, click on users, so we can create a new user. So when you go there, you can just create a new user, okay? Give it a tester. Let's create one so you know how to do it, okay? I don't know. Let's create one. Maybe some of you don't know. Click on the, check this button, provide user access to AWS Management Console. That's what we need, because we need to programmatically communicate with our web service, so, or all the resources that we want to create. Now, you need to attach user to a group, or copy an existing permission that exists, or we can just attach policy directly. Now we will select attach policy directly, and then let's say EC2, ECS. Let's say ECS. We want ECS full access. Okay, but for this demonstration, let's say we will give it administrator access. Then you select that one also. Can select as many as you want. Go to next. Now that we go to next, click create user. We have successfully created our user. This is our console password, and then this is the URL. Nice one. So once we have that, return to user list. Yes, I want to do that. Go to tester. Now go to security credentials. Now we have manage console access, create access keys. Yes, we need to create an access key. That is the one we are going to use. Create access key, select command line interface, because we are going to communicate through a command line interface. Then select I understand, click next, and then description. You can give it any description that you want. Now I have created my access key. So this is how you create your access key. This is your access key, and then this is the secret key. Remember to download the file so that you have it handy, or you can ensure to keep this one very safe, okay? So now we are going to delete. Now we are going to delete our resource. Let's try and delete our resource now. So I will go to IAM user, and then with the tester, I will delete it now. Because you've seen it, I'm going to delete it. Deactivate. Confirm. Now I am deactivating it and deleting it so that you can use it, okay? Now, once we are done with that, we need to go back to our code, and then we can begin the deploying the infrastructure, okay? So we will be fast. I will open the VS Code, and then we will create a new folder. So let's create a new folder called infrastructure. Nice one. This is where all our infrastructure code is going to live, okay? So we will do that. The first folder we need to create in this one is one called security. Create a folder called security. Now this folder called the security is going to help us create all the VPC, the network, everything about our system. We are going to do it here, okay? This is the base layer. That is the base layer we need to do, okay? So we will just copy some code here. I will copy some code, and then I will put it back again. So now we will copy some code, and then we will go and create our YAML file. So we are going to, I hope you can still see it. I hope I didn't move it too much. Maybe I did. Let me adjust it a little bit so you can see well. So now we will create a file called security.yaml. Security.yaml. Now we are going to use CloudFormation templates to create the infrastructure. Okay, so I will copy some code here in my previous video where I break down everything how to deploy the infrastructure. You can also look at that if you want more detail where we did it one by one. Okay, so now with CloudFormation we just need a template version, so AWS template version, and then we'll give a description. And then now with the parameters, these are the environment variables. So the parameters, we are going to give the type string, and then we have the VPC ID. It's going to be a type of a VPC ID. So this is how we reference an AWS resource. So it starts by calling AWS, and then you can select the exact resource that you need. So EC2, here we need the EC2, and then within the EC2 we will have a VPC now, and then with the VPC we will access that ID for the VPC. Again, we will do the same for the cluster security. So cluster security group is how we are going to access our cluster. Okay, this is very, very important, because without the security, without securing your applications or without securing your infrastructure, any threat actor can just break into your system. So you need to ensure that we are giving the best security to it. Now, so we will create also the security group, and then the node security group as well. We will create node security group as well. So with the node security group, how is the cluster going to communicate with each other? Are we going to allow cluster based communication? We just have to configure that as well. When we create a security group, the next thing we need to also create is a cluster to node ingress 443. We need to give 443 permission so we can use HTTPS, okay, in our system as well. Nice. Once we have done that, again, in this section, we also give cluster node to cluster ingress 443 again. So the first one is cluster to the ingress, and then the next one is also node to the cluster ingress. They need to communicate both ways, okay? Because when one send to a receiver, the receiver also needs to send a response. So everything will make much more sense when we go further. Now the next thing is also node to node all traffic. Node to node all traffic. We need to have that communication as well. And then the next thing also is to output these values, because we need to use them. We need the cluster security group ID. We need to use it. So we are going to reference the cluster security group, and then the node security group ID. Also, we are going to ref the node security group. That's all. Node security group. That's all. Node security group. You can see it here. That's all. Cluster ingress. That's all. That's all we need. Okay. That's all we need. Nice one. I will save this one, and then we will move on to the next folder that we need to create. The next folder that we need to create is the network. We need the network. Okay, so again, we will come to the infrastructure. We will create a new folder called network. Now inside the network, create a file called network, the small letters, network.yaml. You can create big letters or anything that you want, but I like to be consistent. Okay, so network.yaml. Again, I'll copy and paste some code here so that we can go through fast. It's just the same, the template version, the description, the parameters that we are going to use, public subnet. That's all. Then the resources that we are going to create inside the network, we will create a VPC here. This is where we are going to create our VPC. And now the next thing we are going to do is also create an internet gateway. This is how we create the internet gateway. Again, we reference AWS EC2 internet gateway. Then we can create it. Remember, we give tags. So tags is just how we can identify which resource it is. Okay, no gimmicks. Now the next thing we need to do is also, don't forget about this error. It's just something with my VS Code settings, but hopefully you don't have such settings, because it's just conflicting with my Kubernetes settings in my VS Code. So the next thing we need to do is also the public we are going to create a public subnet A. So we need two public subnets, one for A and then one for B. Everything we do it in pairs, okay? Just like the Noah in the ark. Everything should be in pairs. Public subnet A, we are going to create that one, and then we also create public subnet B to allow public internet facing communication, okay? But again, why are we creating it in pairs? Now somebody can ask you this in an interview, so why are you creating the resources in pairs? Why don't you just create only like one subnet? For redundancy's sake, you need to ensure that you have two or more subnets, because in case one phase goes down, then you need to be able to use the other phase as well. So we have public subnet B. When we define for public subnet B, again, we need one also for the private subnet A. This is also going to help us with internal communication, okay? We need private subnet so we don't expose our application to the internet. So why do we need a private subnet? Because we are going to keep our backend in our private subnet and our front end in our public subnet, so that clients can use or access our application from the internet. But then with our backend, no one can access our backend from the internet. It's only internal resource, okay? So that's why we create it in a private subnet A. Good job. Once we do that, once we have the private subnet A, then we again, so basically it's just the same. So we are going to select the first availability zone, and then we will give the reference, and then we will give the CDR for the subnet, okay? Again, if you see my other video that I have broken down how we actually write the CloudFormation template file, it will be easier for you to understand. But hey, you can just copy this and it will work for you, okay? So don't panic. Once you know this, it's just simple. It's just plug in and play. You can use it. So we have the private subnet B again. So again, remember, everything we create in pairs for redundancy's sake, okay? Now we create that one, then we need a NAT EIP, elastic IP, so that we can use it to communicate. We will connect that in our client side, okay? So our NAT elastic IP, we are going to create that one as well. Then we need a NAT gateway. The NAT gateway is going to allow communication to the private subnet as well, okay? Now we create the routing tables where we will define who talks to what, okay? Now again, we create public route table. We create a public route table, so we have two of them, everything in pairs. Now we have public subnet A route association. When you create a route table, now you create the association for it. Public subnet B route association, okay? It's going to be for the public subnet B. Good job. The next thing we need to do again is also with the private route table. We create one for the private route table, and then we create the default route, which is going to be the NAT gateway. And then again, we will have a private subnet route A association, okay? And then we have private subnet B route association as well. Then now we will output it. What do we need from this file? We need the VPC ID. We need to ensure that we get the public subnet ID, the public subnet ID for A and B. And then again, we get a public subnet ID for the private subnet A ID, and again for the private subnet B ID as well. Now I will save it and then we will exit. So the next thing we need to do is again to create the parameter. Now that we have created a network, let's create a parameter, okay? So we will create the parameter, and then the parameters. So we will create a folder called parameters. This is where we are going to define some values for our dev infrastructure, and then our production infrastructure, and then our staging infrastructure. That is very key, okay? So we will go to we will go to parameters, and then we will create one file called dev.json. This is where we are going to keep all our environment variables. So this is where you can just change anything that you want, okay, so that it becomes yours as well. Dev.json. So we will copy some code here again and then paste it there. So now the environment name, its value is going to be dev, and then the template key bucket name. So this is for the S3 bucket name, code janitor CFN, then that's template. You can change it to your S3 bucket name, okay. Now the next thing is also a parameter key, template prefix value, and then again we also have the VPC CDR. So that is the block. So we define the CDR for our VPC, and then inside that we will have one for the public subnet A. Its CDR is going to be 10.0.1.0. The next thing is also for the public subnet B. It's also going to be 10.0.2. Very important. Again, the next thing for the private subnet is also going to be 10.0.11. It can be anything you want. You can just say 10.0.25, 10.0. anything. It just needs to be for octet notation. Okay. If you know anything about networking at all, then you know that every private or every IP address have a 4 octet notation, except IPv6. Okay. So we have the API repository name. So we have the API repository name. Where are we going to keep our resources? So we are going to keep our artifacts when we build. So when we build our application, both client side and backend, we are going to push it to an ECR bucket or ECR repo, which is going to be called atlas-dev-api. That's all. And then we also need auth repo. We actually don't need this one, but we can leave it. So API repository name, and then we have one for, we will say database. Okay, database. Let's leave it auth name. It doesn't matter. We can create one also. Can create one for our database, but we are not going to use database in this one. So I'm going to show you how you connect the client side, the client side and the backend side, and then we will take it from there. So we have also one for the client side repository name, and then again we have the EKS cluster role name. So we define EKS cluster role name, a role name for the Kubernetes, Elastic Kubernetes, and then we will have again the cluster name, Atlas Dev EKS cluster. Nice one. So that's it. We just have to ensure we have all these values as well. The type that we desire for our instances, the node desired, the node min size, the node max size, and then the node disk size. So the next phase is again also we will have one for the staging. So if you have one for dev, you definitely need one for staging. Copy the same, and then we will copy the code and put it here. So this one, the value is only, you can pause it and then make sure to type it all out. Okay, the next one is going to be the staging environment. We need the staging environment. So remember, this is a architectural design. Whenever you are designing your system, you need to ensure that you are considering both dev, staging, and production. Don't confuse your local with the dev. Okay, please remember this. Don't confuse your local with the dev. Remember, dev is different. Dev can have its own production link where we push the code to, and then we want to test it. Okay, and then the staging also have the same production link. This is where we ensure that every check and test has passed. Okay, and then if you can even be strict, you also have another environment called test environment. This is also where we are going to do all the stress testing. But for a small to medium application, you just need dev, staging, and production. Now remember to do the same as we did for the staging. Okay, this is how we do it. Again, just remember to have all these values down. That's all. we will go back to the next parameter, and then we will take it from there. So I'll copy this one, copy some code again, and then I'll go to my code. I'll go to my code, and then I'll say prod.json. Now we also paste again, so you can pause and also copy it, the same thing as we did for the staging, and then the production. Remember, this is very repetitive, but once you do it, you have this for life. Whenever you go to an interview, if you don't remember anything, you have to tell them, I will need to refer my documentation. Don't panic, don't be afraid, just be yourself. Okay, just be yourself. Let them understand that you know your shit, you know what you're doing, you know it's not just that you are just copying code and pasting it, you know what you are doing, and then you know why this work with that. Okay, so yeah, that will be it. So now the next thing we need to do, it's also to give permission to our Elastic Kubernetes cluster that we are going to create. So again, we are still on the infrastructure, so we will have to make a folder called EKS. You can make it a file, but it should be in the infrastructure so that we organize everything neatly. Okay, so in case tomorrow something breaks in your EKS, you just look for the EKS folder and look for the file, for the YAML file inside the EKS folder, and just fix it. Okay, so we will make the file called eks.yaml. So it's going to be eks.yaml file we will create here, eks.yaml, and then inside that I will just get some code, and then we will just run through again. But let me close this one so we have a very focused tab. Yes, so within the EKS cluster, again, it's still the same sorry about that. Again, it's still the same CloudFormation template that we are going to reference. We give the description, and then we will give the parameters, the environment variables that we are going to reference in here. So we will need one for the cluster name, and then we also need the environment name as well, the Kubernetes version that we are going to use, the EKS cluster ARN, and then also the public subnet AID, public subnet BID, and then the private subnet AID as well as for the B. Again, we also need the cluster security group ID here. Now we need a node group name, and then we need node instance type. Now we also need the desired size, because when we are creating the EKS, we need to define all these parameters for our instances. Okay, so node min size, node max size, and then the disk size. But remember, using EKS is very expensive, so maybe in the future I'll show you how to deploy on your own EC2 web service. It's going to be much cheaper to do it. At least I pay almost about $70 now, just running about 2 EC2 instances for powering my SaaS application. So maybe you can do the same, but EKS is crazy expensive. So if you are not organization, don't use it yet. Okay, but you can practice with it. After everything, we will tear it down, we will destroy it, so that you get practical experience with EKS as well. Now we will define the resources. So we are going to give the name, so EKS cluster, and then the type is going to be AWS EKS. This one is not EC2, it's EKS cluster. Nice one. Again, the properties that we are going to give is the name. So the cluster name that we already defined, is just the variable, and then the version of the Kubernetes that we want, and then the Amazon resource role name. So it's going to be EKS cluster ARN, and then we also define resources for VPC config. So we need the endpoint. We will endpoint private access true, endpoint public access true as well. Now we also need the security group ID. So here we will also add the security group ID that we already created in our security section. So we also need the subnet ID as well from our network session. Now we will give it a tag. So tags are very important. Now to the EKS node group, we will define the EKS node group here as well.
So it's going to be node group, and then it depends on EKS cluster. When we use depends on, it means that we want this job to finish before we get to the next task. Okay, so it's going to be hierarchy. That is how our algorithm should work. When you hear about algorithm, it's just a systematic approach how you want to solve a particular problem. So properties, we have the cluster name. We will reference the cluster name here as well. Now we have the node group name again, reference the node group name. The node role, we will define that as well. Then the subnets. Here again, we add the subnet to the node group as well. And then the scaling config, so the min size. So we will use node min size. So we define that. The desired size, we also know desired size, that's the variable we will reference. And then the max size, so the maximum that we are allowed to scale to. Then the AMI type, it's going to be this AMI type. You can look on AWS and find any AMI type that you want. Okay, now the capacity should be on demand, and then sorry, and then the disk size is also going to be no disk size. Now we will also define the instance type as well, and again we will give labels. So the tag as well, we need to always tag all our resources. Okay, now we will save it, and then we will move on to the next phase. The next phase that we will do will be something with the IAM permission, because EKS requires some specific permissions, so we need to ensure that we are giving that. So create a folder IAM, identity and access management. Okay, copy some code, and then I will come back here again. So once I get the code, this file is going to be EKS IAM.yaml. So EKS IAM.yaml file, EKS IAM.yaml file. Let's get the code and put it here. Nice. Again, it's just the same. The template name, you don't need me to keep repeating myself. You can pause it and let's go through. Okay, sorry about that. So it's the template name. We have the parameters. Now we will also define the core resources as well. So again, we will just define the core resources, and then we will define the policy type that we want. That's all. And then we also do one for the EKS node role as well. That's it. Then we output it. That's it. So remember to pause it and just get the same code down. Okay, then also you can check the description down below for the GitHub repo link, and then you can just copy that code and then place it there. Okay, place it in your folder and make the adjustment as you see fit. Now the next phase we are going to do is to make our root folder. So we will make our roots folder. So this is where we are going to put everything together. So this is where we are going to put everything together. So the root file, and then we will do root.yaml. We will do root.yaml, and then now we will wire everything together. This is very important. So we will have again the template version, and then the same parameters that we want to pass into our resources. Okay, so these are all the parameters that we want. Now coming to the resource aspect, this is where we need it. So the first resource we are going to create is the network stack. We need to create the network stack. Okay, so with the network stack, we give it the name, so cloud formation stack, and then the properties are going to be the template URL. So first of all, we are going to push our files into an S3 bucket. So the template URL where this network file can get its file for the cloud formation to run it from. So it's going to be in this path. So it's AWS S3 bucket, and then the path is the template prefix name that we give. So that's the environment variable here, template prefix here, confirm. That's the environment variable that we are just referencing. So you do this so that you don't just share your environment variables. And when you do this also, again, imagine if you have hard code everything inside the code base, and then now tomorrow you just want to change the S3 buckets to maybe another name. So you need to go into the same code, change S3 bucket everywhere you've used it. It's not manageable. It's better to have a place to keep it. That's why we have which ones did we create? The parameters. That's why we have the parameters. So we just define them there. Okay. So it's going to be the first one. The network is going to use network.yaml, which we already defined. And then the next one, the security stack, also is going to also again use the security.yaml. That's it. Now the next aspect also, we need to create the ECR bucket. So we need to create ECR bucket. Now we do this, I can see we don't have the ECR yet, so we need to ensure that we have the ECR as well. So let's create the ECR before we continue. Maybe let's finish here so that we will let me take you through here so that we will go to the ECR, finish it out, and then I'll show you how to push the code to S3 bucket, and then we will take it from there. Okay. So the next stack is also going to be the IAM stack. We need to create that as well. We are going to create the stack as well though. So its file is going to be EKS IAM file that we already defined. And then the next stack we also need to create is also EKS stack. So this is the Kubernetes. So this is how this is how we get AWS to deploy Kubernetes and manage it for us. Again, if you are using EKS for an organization, this is best suit. But if you're a small to medium scale business, I'll recommend you to burn the candles and just do everything manually by yourself. You know, you can just deploy Kubernetes. I already have some videos and some resources that you can always just use, deploy Kubernetes onto your web servers and start to manage your own application. Because the more you give the power away to AWS, the efficient your resources become, but the more expensive as well your resources gets. Okay, so maybe if you have more money you want to throw away, you can send some my way. Okay, so we will also give the parameters there as well. So Kubernetes version, the EKS cluster role, the EKS role ARN, and then the public subnet with the same thing we already just defined. We will just pass the same values here. So that's all we need to pass to when you are creating the Elastic Kubernetes. You will pass all these values. Okay, so we need all these values. That's why we had to create them one by one. That's it. So we will save the file, save the root file. Now we will make the folder called ECR, and then we will get some code here. So let's make the folder called ECR, not RCR. Okay, remember I made a mistake, so it's ECR, not RCR. Rename ECR, and then we will give it the name ECR.yaml for the file. So ECR.yaml for the file, and then I'll get some code, and then we will put it here. Nice. So again, we are defining the ECR resources. So its parameters is going to be the environment name, the API repository name, the auth repository name, the front end repository name as well. Now we also give resources. So API repository. So the API repository name, we have to create the ECR, and then you will use it. So one for the API repository, one bucket for the auth repository, and then again one bucket for the front end repository. That's all. So it just creates those ECR bucket for us instead of us going to create it all manually. Okay, I will clear my screen now. So now in order for us to run this, first of all we need to run some code. We need to run some code manually before. I want to show you this manually, how we load it to the S3 bucket before we automate it, so we don't have to do it manually again, okay? Because we are going to use CI/CD pipeline to deploy this for us. So first of all, I would get some code here. But remember, before all this, you have run AWS configure, and you have configured all your AWS credentials, okay? So I have done it, so we are not going to do it. First of all, we are going to load the S3, we are going to load into the S3 bucket the network file, okay? So let's do that. Okay, we do not have this path. So we do not have this path, so probably, so it's infrastructure. So here we did it infrastructure instead of infra. So all we need to do is just to change this name for our root folder. So infra, and then we will just continue. So let's do it. Let's clear the screen. You can also maintain the infrastructure and just change it, okay? So I'll paste it here again. So it should be from, we are copying from infra CloudFormation, because we don't have CloudFormation. You know what? I'm just going to edit it. Infra CloudFormation. We don't have CloudFormation folder, so it's going to be infra network and then the network.yaml. Now let's load it. Hopefully this time around it works successfully. We have loaded that. Nice one. Let's be sorry about that. Let's be smart. We are going to make a file, deploy.sh file. Deploy.sh file. Okay. So we are just going to get some code here. So shebang, and then we will get all the bash script here. Nice one. And then first line that we did was AWS infra. Nice one. And then the next one we need to do is AWS again, CloudFormation security. So we need the security. So let's run this one. Let's see if we get our file into the S3 bucket. Good job. Our file has been loaded to the S3 bucket. Now the next thing we need to do again is also to copy the ECR. Let's get the ECR there. I'll copy it now and run it. We have successfully done that also, so no errors. But don't panic if you get errors, okay? Use ChatGPT to debug. You know, you have to be fast. And then again, we have to copy this file eks.im into our S3 buckets. So we will run this one too. And then we will do the last step for the EKS. So last step for the EKS file, we need to get that. So remember, I just remove it here and then I'll just paste it here. So that's not the right code. I'll go out of it, clear the screen, and then I'll use it here. So once we are done with that, now we will go with the deploy the stack. So now we are going to deploy the stack. I will just copy some code here and then we will continue. Yes, so this is the commands to deploy the stack. So it is going to be AWS CloudFormation deploy -- template. I don't have autocomplete. -- template file, and then our template file is going to be our
main file is going to be root.yaml, nice, infra, and then root, and then root.yaml file. Now the environment stack, so dash stack name, we need stack name, very crucial. So it's going to be atlas dash env, so the environment that we are going to choose. Okay, atlas dash env, and then I believe the next thing is the capabilities. We give the capabilities as well, and then the parameter override. The parameter override. So it's going to be, the file part is going to be this one, the environment.json. I believe this one will get an error because we need to really specify, that endpoint. So we need to specify that endpoint. You know what, I'll just open my codex and then we will just get the command to run ASAP. So I am testing locally from my machine. Give me the exact command to run my scripts. So I believe we just missed the what do you call it, the environment reference. That's it. So let's see what we get from codex, and then from there we can fix it much better. Yeah, so our environment that we are going to give is just the dev environment. That's it, like just as said. Yeah, but I just want to add it, not like that. So shouldn't we just add dev at the end of this command instead of exporting the env? Okay, so let's do it. So we just export the command and the environment variable, because when we go into the GitHub, because we are going to use GitHub Actions to deploy it, so that's where we are going to define all these environment variables. So whenever we are in staging, if you want a staging environment, then you deploy a staging environment. Okay, but that's what I'm going to show you. So we'll copy the code and then we just paste it here, and then we will run it. So now it's going to create all our stack. Now the validation field, when calling the creation change stack. Okay, so we got a validation field. So let's debug with our codex here. So basically, because I have not delayed some of the resources beforehand, so that I created, that's why we are getting this. So we need to get it. So yeah, so we need to get it. Let's get it, and then now we can delete it now. So these are the resources that are already existing in my AWS account, so that's why we weren't allowed to create. So now let's delete it, and then we will be able to create it. So I'm going to make a file here and update it. So infra.readme.md. so it's always better to always write all your debugging down, because in the future you can use this for your
your run book. Okay, so whenever you are running into errors like this, you will know how to debug them ASAP.
So we still got an error here. So before we make our run book, let's just get to fix this problem right. So again, I'll describe this one. And then we will give it to codes, and then let's see how we can delete it ASAP. Run it here, yes. So there we go, here it is. So we get the event, and then we will just look for that resources that are already existing that is causing us to not be able to get our task done. So now we can delete it now. Nice one. So I'll clear my screen and then we'll delete it with false. Nice. Let's see. Yes, it worked. And then we can now delete all the resources that already exist there before, and then we will continue. So delete existing resources. We will make it better. We just make the rough sketch here. So here is a command to delete, and here's a command to delete, and then again also the first command we use is to describe it, so we need to get that one down as well. Yes, inspect the resources. Inspect resources. Now you get this one down as well. So again, remember, I'm showing you all what goes on behind the background, not just the fancy, I come and sit here and then everything is working and then you say, wow, this guy is genius. This is what goes on behind the back doors. So you have to also learn it, and then you can also be able to do this for yourself. Okay, you don't need to be in this giant world alone. We are in it together. Okay, my friend. So now we've deleted it. Let's deploy. So again, just the same command that we just ran is just that command that we are going to run again. That is all. We will run the deploy now. Nice. Now it's waiting for the resources. So I'll save my file. I'll save my file. Now what I'm going to tell coders is to improve our deployment script, and then also to ensure that we have another one for destroy, where we will destroy everything cleanly. Okay, so improve. If you have what they call it, Claude or anything else, just use it. Okay, don't rush. So improve our deploy.sh scripts so that the deployment we don't need that one because we already have this one done. So yeah, we don't need that one. Yeah, we don't need it. So the main thing we need to do is to run one. We need to make the destroy one. So make a destroy.sh file where we can just run to destroy our infrastructure. So it's always very important when we are testing like this, we need to learn how to destroy. Okay, but when you are in a production environment, please do not go and destroy to recreate. It's very bad. You need to
to debug. Okay, you need to take time and debug. When you go to an interview and they ask you, John, are you going to, when it comes to debugging, are you going to tear down the whole system and then bring it up again? If you say you are going to tear down the whole system, you can be sarcastic and say, yeah, of course, somebody can decide to tear it down, but you would recommend that because it's much better to go into details what happened and then be able to document it so that in the near future you have a round book to reference. That's all. Very simple. Don't oversell yourself as well. Okay, so now we have the destroy script also done. Have it handy now, so it's going to delete everything. Sorry about that. So it's going to delete everything and then we are good to go. We are good to go. Let's go to our AWS account and then we can see what's going on. So let me minimize this time around so I do not forget. So I will minimize and then now we'll go into CloudFormation. Oh, okay, we need to sign in. Definitely, I knew. Let me get my login and then I'll sign in. 92, yes. Then I'll sign in again. So once I'm done, we will go to CloudFormation. Then now we can see our stack is being created. Some are still in the process of creating. So we can see the IAM stack is done, the network stack is done, the security stack is done, and then the ECR stack is done. So let's check ECR if we have ECR repositories. So ECR repositories. Now you can see we have Atlas Dev, Atlas Auth Atlas Dev front end. So we are good to go. We are good to go. This is good. This is very, very, very good. Imagine if you have to create all these resources one by one as a DevOps engineer or as a platform engineer or as a SRC engineer. It's tedious, my friend. You need to be able to learn Terraform or learn CloudFormation template and be able to define resources as code, and then you'll be able to deploy them at scale. Now, when you do this, again, your system becomes very modular, very maintainable, and again, also very scalable. So imagine you have a cross-functional team that you need to work with. And now remember also, now your company requires you to deploy across a cross region. Now we just did it in US is one. Now we want, let's say we have another team in Asia Pacific, so we need to deploy the same resources in AP South 1. We have to do it, or Canada. We have to be able to do it, but then you can't go there and create everything one by one again. It's much better that you know how to use Terraform or CloudFormation. But even with CloudFormation, you can go into much details by creating a CloudFormation stack template that you will just replicate across multi-region, and then easy to go. Okay, easy to go, easy peasy. Let's wait. It's going to take a long time for this to finish. So once this finishes, then I will come back and then we will continue. So even before it completes, you know what? Let's move on, okay? Because we wait whilst it does its job. We would move on. So the main thing we need to do. So first thing done. Let's say configure infra. This should be the number one thing we need to do. It should be number one thing we need to do. All these ones will come later, so we'll put it here. Configure infra, we will check it because
we are done. And then when we have not used KDS yet, but now we need to configure our infra for CI/CD. This is key. So we are going to, so that we don't have to run the code manually again for us to deploy our infrastructure. It's just going to be automated. So in order to create a GitHub CI/CD, you need a folder. That folder needs to be this way. It needs to be called .github. Done. Inside that folder, you need another folder called workflows. That's the pattern Git Actions uses. Workflows. I believe it's workflows. So yeah, once we are done with the workflows, then now we can build one for dev. So we can build one for dev. So now inside workflows, then we will build one for dev. So dev dot API let's say dev hyphen build dot YAML. You know what? Dev dot YAML, because this is for our development environment. So let's say your organization wants you to create a separate environment for development, a separate environment for staging, and a separate environment for production. This is what you need to do, okay? But if you are a small scale, or if you are trying to run your own SaaS business, don't go and do these three things. Only use one. Stick to one, otherwise you can't pay the bill. So dev.yaml, we are going to get some. We are going to this one. I want to go with you one by one so that we will learn from it. Okay. So let me close my codex for now. He's our good friend. He will come back again. So now we are going to give the name. So we give the name for our GitHub action. So it's going to be devx dev workflow, dev workflow, CI/CD workflow. That's all. Then now on which main stage do we want this to run? Okay, so now on push. Nice. On push. So whenever we push this, and then the branches that we want this to work in. Okay, so now remember, it is a dev branch. So if we go back to, let's go back to the browser. Let's refresh this and see our status is still working. So if we go back to our code, let's go back to our code. Now we can see we have three branches. So one for dev. So we want it to work in this branch, not in master or not in staging. Okay, so we will see. We would open my code again. So it's going to be dev, not main. It's dev. So on pull request is also dev. Okay. Once we have done that, then we also need to define the path. So which path must we track? So we need, whenever something changes, inside a folder called service/atlas API, because that is our API that we are going to build. Whenever something changes in there, we need to run our workflow here. Okay, and then whenever something also changes in this file as well,
whenever something changes in this folder, so the deploy khs and then the overlay folder dash slash dev, we need to run it. Now we need to also, again, whenever something changes inside the GitHub workflow, we need to run it. So it is dev.yaml. Remember, dev.yaml. So whenever we make adjustment to this file, we need to run our code. Nice one. So workflow dispatch, we need to define workflow dispatch. So workflow dispatch, did we need one for workflow dispatch? Yeah, we would do that. I'll get some code here and then we will use it here inside the workflow dispatch. So it is path, not path, okay? Remember, it is path, not path. So the paths and then the workflow dispatch. So the workflow dispatch, the actions that we need to do, we need one for what we want to do for deploy. Okay, so the deploy is going to be manual, and then we also need one for destroy. Again, we also need one environment. So the environment is going to be dev. So that is the environment that we are going to select, and then the options are going to be dev and prod. Okay. Yes, so we are done with that one, the dispatch. But because we are going to use Argo CD also, we need to give some permission here. We need to give permission to our GitHub workflow to be triggered again. So it's going to be, so workflow on this line, yes, permission, and then content, and then we say write. Give write permission, because GitHub workflow likes to modify, Argo CD would modify our resources, so we need to write here as well. So yeah, we are going to write here. Why do we face all these errors? It will go away. Yeah. So let's also configure the environment variables that we need. We are going to need some environment variables as well. So the env variables, we have our environment variables configured. Okay. Yeah, there's something again with my shimmer again, but don't worry. Now, before anything else, before it stops screaming at us, we need to go back one more, probably. Yeah, we need to go back one more. So yes, we need to go back one more before it stops screaming at us. Okay. So this one needs to go forward one more again. Yes, good job. So just the indentation that was just screaming at us. Oh my God. It can happen, so be mindful of that. Okay. So the next thing we need to do is the jobs, so that the top screaming error will also go away. So we are going to do one. The first thing we are going to do is build, test, scan, push, and update the dev. That's good. And we only want to do this if this job is from Argo CD. So if it's from a bot, then we would do it. Okay, that's all. So we are going to run on, it's going to run on Ubuntu latest, that's all. But before that, I want you to see how this job will run also. So we will say test, and then we say runs on Ubuntu latest, and then the steps going to be name, echo test. Yes, so now we run this command, echo this test job, to check for the workflow triggered correctly, confirm. So once that is done, let's go back to our browser and see if our stack is done. Good job, our resources has successfully been created. Nice. That's amazing. That's amazing. So if you're able to get the same code, you will just be able to have a functioning EKS cluster. Okay, so the next thing we need to do, first of all, we have this one. So let's not get ahead of ourselves. Now I'm all excited. Yeah, I'm all excited, but let's not get ahead of ourselves. So yeah, let's go to the dev branch. Now you can see the only code we have here is the tax, to do tax. So let's update it. I will now update it. Oh, not my SaaS business. I will now update it. So dev.yaml, and then you say git add, git commit. Please always give a meaningful commit message. Okay, initial CI/CD pipeline setup, and git push. Now we push it to GitHub, and then let's see what will happen. So now that we push it to GitHub, let's see what will happen. Now we've pushed a code to GitHub. In our dev, we can see now we have the infra code here, and then we have the workflow here. Let's check actions, what is happening. Boom, pipeline failed. So invalid workflow. No steps defined in steps, and no workflow called uses for the following job. Yeah, we know that. But to get it to work, you know what, my friend, let's remove this one so that we would be okay from it. So git add, git commit -m, and then we say checking if pipeline pass. So whenever you are doing, remember to test, because it's going to be try and error until you get there. Okay, you need to do the scientist approach. If you know anything about science, you have to know that every invention that we have gotten as human came from try and error. Nothing came from perfection. Okay, now you can see we have successfully passed it. Yes, so going forward, we would remove this test, and then we will, let's put that one back, and then we will remove this one. That was just for show. Okay, now let's get to business. But again, you didn't see that if it passed, and minimize. So again, now it passed here. So if you go back to the code, you can see in the master branch, we do not have anything to do with the infrastructure, because we have not merged the code to the infrastructure yet. That is good. Only senior developers needs to merge the code into infrastructure. I'm going to show you how we will configure all those. Okay, so this is the dirty work you need to get done even before you start to build your application. And if you do this, if you practice these infrastructures 1, 2, 3, it becomes a thing of the past. Now you can just do it without thinking about it. You can just configure it easily. Okay, so we would go to dev branch. You see dev branch has the infra and then the GitHub actions here. Again, staging also has nothing here, so yes, that is good. Our code is not being messed up. Okay, so later you can have feature branch, or when the developers create a feature, then it can merge into the dev branch and then it will deploy, and then you see whooly, everything is up and running. So yeah, now we have let's go back to our code and then consult with our friend. So I'll open Codex here again. Now infra is deployed, so give me the command to configure. Give me the command for kubeconfig. Yeah, that's all we need, so we can start to use Kubernetes with EKS from our command line. Okay, nice one. So we will go to our command line. I'll clear my screen and then I will run this command. Now also I'll tell it to update our readme for the infra, so that we have this. Update the readme for the infra, so we have all this handy to go. Nice one. So once it's doing it for us, nice, we can see we have it configured. Nice one. So we run kubectl get nodes. Now we can get our nodes in our AWS cluster. Now we are running the Kubernetes version 1.30. I think the latest version is 1.34. This is good. Okay, get ports dash all. I like to use the earlier, so now I don't. Okay, you didn't see that because I don't have this terminal open. Yeah, let's do it here. So we have kubectl get nodes. So whenever you hear node, please don't think too much. Don't think like a node is something crazy, because sometimes with Kubernetes people can make the topics very complex. When you hear a node, you have to think about a node just as a computer. So they say 5 nodes. It's 5 computers. We have deployed only 2 EC2 instances for our EKS. So EKS only uses 2 instances. So there are 2 virtual machines in AWS cloud. That is all we need. Okay, so it's just like, don't overthink it too much. A node is a computer. A pod is an application. That is all. That is the simplest I can just make it for you, so that you don't have to crack your brain like, what is a pod? Pod is crazy. They say something pod. No, my friend, pod is an application. A node is a computer. An application needs to run on a computer. That's all. So we would get all the pod get pods dash a, all pods. We don't have not k, my friend. I like to use the abbreviation, so I will configure it later. So kubectl get pods. Now we get all the pods in our resources, so we can see we have all these pods. Core DNS configured for us. Everything is configured correctly. Nice one. Nice. We are done. So we can begin to build the infrastructure for our application before we even begin. But again, if you are working in a team, remember to consult the developers how the application is running. So you need to know how the backend is running, on which port the backend is running, and how the backend is communicating to the front end, because this will help you in your designing for the platform. Okay, this will help you a lot designing your platform. So remember to do that. Okay, so let's take a break now, and then I will get something to drink for my throat because my throat really hurts so bad. So also remember to get something to drink. Take your time. This should be this project. When you build it, you get confidence in yourself. You start to get confidence in yourself, and you'll be able to talk about this architecture without needing to even overthink it too much. You shouldn't overthink, okay, whenever you are doing something. Even if you are doing it for yourself, or you are trying to get a job, or you are even trying to build your own business. This is very key to do. You don't, in this day and age, if you're also a developer trying to go into DevOps, you need to take your time and learn a little bit about these YAML files, and then you'll be good to go. Okay, so we are going to get more in depth with YAML file. You need to love it. I love it. So now, after our break, we can continue where we left off now. So we have first of all tested our first job, which we know that everything is working. These environment variables, keep an eye on them, okay? Just keep an eye on them, because we are going to see why we need to do this environment variable. So please bear in mind, keep an eye on them, and then I'll also show you where we did it. All right. So the next step is going to be, we need to give the steps for this build job. So we have steps. And then with the steps, first of all, we need to check out the repository. Okay, so first of all, check out repository. Remember, your indentation should always be right. So check out repository. We are going to check out the repo. Checking out the repo basically means that we are getting our code base onto the Ubuntu web server, okay, that is running on GitHub Run Actions. Okay, so GitHub Runners uses the Ubuntu, so that's where we are putting our code now, so that we can do some checks over there. Now we are going to use, so we have uses, we have this key uses, and then the action is going to be Actions version 4. So GitHub Actions version 4. If you want to find out where we get all these values, you can check GitHub Marketplace. So let me show you how you can find where to get these values. So if you go to, let's go to the browser. So if we go to the browser, let me minimize so that you can see. Okay, I keep forgetting. So if you go to the browser, then you go to GitHub Marketplace. So GitHub Marketplace, this is where you can find actions. So you say actions, then we can find GitHub Actions, checkouts, search for checkout. Yeah, checkouts, exactly. So now we even have version 5. Okay, the latest is version 5, but I believe version 4 is a stable one, so that's what we are going to stick to for now. Okay, so let's go back to our code. Let's get some work done. So going back to our code, getting some work done, and then we also, now we fetch the code onto our Ubuntu server. Again, we also give another step, which is going to be setting up a node environment. So we are going to set up the node environment, because we are going to basically deploy a Node.js app. Okay, so Node, we are going to also use version 6, so you can find the same on the GitHub Marketplace. So uses actions/setup Node version 6. Okay, from official Node. Okay, can use that one. So now we can give the version of Node that we want to use. Okay, so we will say Node version. We have something with Node version
node version, we will go with node 22, I believe. Node 22, yeah. I think we have node 24 now. Let me check. NVM node, let me clear my screen. Node -v. So yeah, I have node 24, so node 24 is available, so we will use node 24. And then the cache package is going to be npm. Cache package is going to be npm, so we will get these values also here. Cache package is going to be npm, and then the cache dependency path is going to be service atlas, and then we are going to use this package.json. That's all. Nice one. So it's going to be Atlas API. That's where we are going to have our backend code. Nice. So once we do that, we need to, because we do not have the backend code yet, do not worry, we will just spin out some backend code, and then we'll be able to use it. Okay, so once we do that, we are going to move on to the next step. So we do the caching, and then the next step is to install the dependencies. Okay, next step, install dependencies. So we will install dependencies, and then the working directory, we are going to set a working directory. So a working directory is going to be the service directory that we serve. So do we even have that as an environment variable? We should make that environment variable. So if you go to our env, if we come to our env, yes, we do have it. So services, and then we have one with atlas API. That is what the folder going to hold our API code will live. So yeah, so basically we just reference that. So we are making sure that we are running this command in this root folder. So once we do that, the next job is also to do some quality code check, which is linting the code, making sure that the code meets standards. Okay, so again, we will also run the lint. So by just running npm run lint, and then it will lint our code for us, ensuring that this check will also pass. Nice one. Then the next phase is going to be the test phase. So we are going to run the test phase. So now we will have to test our application. So we will run npm test to test our application. So whenever you build an application, remember, you need to lint your code, ensure that your code quality is being met, and then all the unit tests that you've written for your program should also be met. Okay, so we have that one done, and then the next stage is we have to build our app. We need to build our app. So we are going to build our app. Again, we still ensure that we are in that root directory. Still ensure that we are in that root directory, and then we will just run npm build to just build our application. That is it. That is it. So once we do that, we need to push our image to AWS repository, so we are going to use ECR repository. So we need to ensure that we have that. Okay, so the next step we are going to do is to ensure that we resolve AWS account and registry. Nice. So first of all, again, we will have one with the name. One with name, and then ID will be account. So account, it can be anything you want. You can give any ID that you want, okay? And then now with the run, when we pipe it, we can run many commands instead of writing a command like this. So when we instead of writing a command on one line, when we pipe it, we can run as many commands that we want. So I will get some command and then we will put it here. So yes, that's done. So we are basically getting the ECR password for our AWS account. That's all. That is all. That is it. So the next step is for us to set image URI. So we need to set the image URI. We are going to set the image URI. So we would also, next step here, we will set the image URI. So we need to set the image URI. But why do we need to set that? Because you see, whenever we are going to build the application, we are going to ensure that we are going to tag our application with the either the GitHub run number or the SHA. Okay, so whenever we run a GitHub job, we get a GitHub run number or we get an ID like a SHA that we can use to identify that build. Okay, so we will do that step. So first of all, we'll do the build step. Let me remove this one and get this here. We do the build step. ID is going to be image, and then the next step is going to be the run command. Run command again. Now let's pipe it. I like to pipe it. Let's pipe it, and then get some command here. So yes, so all we are doing is we are just going to get the URL which we are referencing here. So in the step account, so that's why we gave the ID account here. In that field, when we output it outputs. We are going to get the output, and then we would use the registry that we have. So the registry and then the ECR repository registry, and then we would give the GitHub SHA identity to it. Then we will output it. That's all. So we output into this variable. That's all. Now we have to build our Docker image. Now we are going to build our Docker image. So when we set, then we build a Docker image. Okay, so let's build our Docker image. And then the next step is going to working directory. We will ensure that we are in the same working directory. We got too many errors, which means my indentation is not quite right. So name, let me get this one correct. So we get a name here, and then we get the working directory here, and then we would also give the run command. We also give the run command. Okay, so the indentation is not quite right. The indentation is not quite right. Yes. So now we've got it. So it stopped screaming at us. So yeah, we are just going to build the Docker image in this next step. And then what we will be doing here is just that the working directory is, we are going to set the working directory where we are going to run this command. So inside our main root folder, we are going to have a Docker file which we will define for our application. Okay, so again, when you are working in a team, you ask the application developers how the app is being packaged. So it's either
the developer or the full stack developer, whoever maintains the application side, has already built a Docker file, or you as a platform engineer or the DevOps engineer will be required to build the Docker image for that specific project. Okay, and then you ensure that every project folder has its Docker file. So front end will have one, the back end will have one. Then also, if you are doing a self-host database, then you either make one, or later on I can also show you how we do it in a production real scale. Okay, so don't need to worry about that so much, but know how to build one for the front end and then one for the back end, and then how to connect them. That's all. So the next step is also to tag our image for ECR. So we will tag the image for ECR. Nice one. So we will go down and then we will do another step. It's just repetitive, but when you do this once, my friend, you would have this code down and then you just have to maintain it. That's all you have to do. So we tag it. So docker tag, this is the command to also tag it. Again, we use the run command to run docker tag atlas API, and then the GitHub SHA that we already got. So when we got a SHA, and then we output it into this variable to save it, and then in the then we will give the tag, so the steps image output, and then we use that URI. That's all. That's how we tag it. The next thing we have to do is to scan our image. So for security purposes, we need to scan our images. So we are going to use Trivy to scan our images. Okay, so we can use SBOM to also scan our images, just so that we can ensure that there is no security vulnerability in any of the packages that we have used in our application. So imagine you use Axios for communication between your front end and back end, and then Axios has been breached and you do not know about it. Using a image, scanning your image like this with Trivy would help you ensure that you are deploying a safe application onto your platform. Okay, so don't give hackers the chance to get into your platform. Okay, so the next thing we will use Aqua Security. So from Aqua Security, we will use the Trivy action, this version. Okay, so that's it. We are going to get this version. If you go on Docker Hub, if you go on, I said Docker Hub, if you go on GitHub Marketplace, you should be able to find it. Okay, so next we would also add some values that we want. So we are just going to reference the image. So this is the image that we are going to scan. We are going to scan that Docker image, and then the format should be in a table form, and then exit if any error happens. That's why we have the exit code 1. Okay, so if you put 0, nothing will happen if error exists. So ignore unfixed, so that's true. And then the severity, the measurement that we want to actually break this pipeline on, is going to be critical and high. So anything that is critical or high, we will break it. But we will see if you want one for medium, you will see all those ones. Okay, so the next thing is to push that image that we built to the ECR repository. So we need to push that image we built to the ECR repo. So we have one for push image to the ECR repo. All we have to do is to docker push, and then we will push it to the ECR repository. That's it. Good job. Good job. Now we have to update our tags. So we are going to update our tags. Don't worry, you have to do this only once, and then that's it. We need to update our tags. So whenever we push an image to our ECR repository, then we need to also update our tags in our Kubernetes files that we will define for our application. Okay, we are doing this, making sure that we have done it correctly, and then we will move on to the next phases. Okay, so we are going to ensure that we are updating the tags for all the YAML files for our Kubernetes. Okay, Kubernetes deployment. Okay, so we would also run this command. So we are going to run this command to update. Wrong indentation again. So the next step is run again, pipe it, and then we have wrong indentation as well. Okay, let's fix the indentation. The indentation is always a problem. Yeah, now we've got it fixed. Nice. So now we can run this command. So we are just going to set in the new tag that we have got. Okay, so we are just going to set in the new tags in our Kubernetes folder. In our Kubernetes folder, we are going to have customized watching all our deployment. So that is where we are going to update. We are going to update that image tag in our customized YAML files. Okay, so we will use customize to manage it. Some people like to use Helm to manage their deployment resources, which is very good. I think Helm is one of the popular tools to manage all your Kubernetes resources very effectively, but customize I find also very effective and does the job quite effectively, and for me I choose customize. Helm can be a bit tedious, so I like to play with customize, but I can still work with Helm, no doubt about that. But actually I like to work with customize because even in my SaaS application I use customize. It's very easy to do. So the next step is to commit it. So now we have to commit and update our overlays. Okay, so we would run this actions. So we are going to use Argo CD to do all this. Okay, so we will run this commands here. So git config username, so we get a GitHub actions, and then the git config user email. We are just going to get the email here, and then the next thing to do is to add this repo. We have to update this repo. We are going to update this file. Okay, this file we are going to update. And what are we going to do here? So we need to give some changes here. So we will get some command here again. I'll come down here. So if there is a difference in the cache, then echo no changes. Okay, so if there is nothing, then we will just exit. Okay, so we don't wait. But then if all conditions are met and then there's something that has changed, then we need to actually commit and then push back to our GitHub repository. Okay, so we would do the git commit, update dev image tag, and then we will use the tag image here, and then we will just push it. Okay, so it will all be done automatically for us. So whenever we update our Kubernetes resources, then Argo CD is going to help going to sync our code with our Kubernetes resources, which is very smart actually, because even in my SaaS business, I did not use Argo CD. I had to. This was one of the big challenges that I faced, and I had to do a lot of this manually. So there was I think going forward, I'm going to update my YAML files in my production environment with Argo CD, which you are going to see. It's going to be very powerful. Nice one. So we are done. So now we are done. Now that we are done, we will move on. We have one for what do you call it, the dev environment.
So we are only going to run this in the dev environment. Okay, so we are just going to replicate this for staging and then for deployment as well. Okay, but if you're a small scale business, I recommend you sticking to one. So let's go back to our code. We are done with our CI/CD pipeline. Now that we are done with our CI/CD pipeline, we just need to set up our, what do we call it? We need to set up our backend. Okay, we need to set up our backend. So we need to just set up our Node.js backend. So first of all, we will set up a Node.js backend. If you don't know how to do it, I will show you. So we will create a folder called services. We will create a new folder called services. And then inside these services, we are going to have Atlas API. Remember that folder part, it needs to be the same, Atlas API. That's it inside the service. So inside that one, we have to start our Node.js package, our Node.js application. So I have already made some pre-made resources in my GitHub repo, which you can grab. I will also leave a link in the description down below. But first of all, hey, let's just go to our good friend. I will not use coders yet. Let's go to our good friend, and then let's set up a Node.js project with TypeScript. Everybody loves TypeScript, so with TypeScript. Okay, fast. So we are just going to get a command to set it up. So instead of, yes, so we will get this and then we will just run it fast. Okay, so don't focus on making this one, it's not necessary, it just throws you away. Okay, so you need to know what you are doing, otherwise again it is going to throw you away. I don't want to create all this folder, it's not needed. We know what we want to do, just I needed the commands fast. So it's just going to be npm init dash init dash y, npm init dash y, npm init. So we initialize the project and then npm init dash y, so which means we say yes to everything. God damn it, no, I made a mistake. So not here, please remember, see, I made a mistake. So I did not need to initialize in the root folder. So open the terminal in the Atlas API and then run npm init dash y. This will give us the package.json file. You can modify it as much as you want, it's no problem. Now let's install express.env, and then we would also install the TypeScript. So I'll run these commands. These are very crucial for us setting up our TypeScript in our project. So I'll run this command. We install it. Nice. So we are installing some packages. Okay, so our packages are done. Now our system is ready. So all we need to do is also to create a source directory, and then all we need to do is to create a source directory. So go in my code base, I'll clear the screen. We'll create a folder called source src, and then in that folder we are just going to have a file called index.ts. That is going to be our root file, okay, the root folder into our application. So here we import import express from express, import express from express, declared but never read. Okay, so no problem. Import express from express, import .env from .env. Yes, so that's good. Now let's go into our package.json and do some adjustments. So all these ones you need to ask the developer how the app is being configured so that you know how to run your application. Okay, so go in my package.json. I'll just copy some code into my package.json and then I'll run you through. So let's go into our code again. I did not show you the browser, sorry about that. Yes, now I remember. So I go back again. So yes, this was just the command we initialized, npm init-y, and then we install this packages, npm install express.env, and then we install TypeScript and its relevance, and then we also initialize our TypeScript project. That's it. So whilst this is not an API course, this is just a glimpse into how to build a Node.js application. So we would also go back to the code base. So once we are in the code base, then I will just replace my package.json and then we will run through. So all we need to do in the package.json, don't panic. The only thing you need to do in the package.json is to just add the script tags. Okay, so we need one for the build. So the build is going to be the TSC, so the TypeScript compiler, and then we also need how to start our application. Node, we start our application with Node, and then we are going to start it from this folder because when we build our application, it's going to be in the this folder. Okay, and then we will have one for dev. So TS node, we will start the application as well. Nice one. So let's also get the TypeScript configuration for our application. So the TypeScript configuration for our application is also going to be correct. Everything is correct here. Everything is correct here. Nice one. So all you need is this tsconfig.json. This is just when you are building a real production application. This is not what you need. Okay, I would link a link in the description down below, or you can go to Google or ask ChatGPT to give you a real production tsconfig application. Okay, so you can type check all your resources very well. So once we do that, let's go back to our browser and then see what ChatGPT says. So yes, the same tsconfig we have here, and then we create a .env file. Yes, so if you don't know what a .env file is or an env file, if you don't know what it is basically an environment variables where we are just going to keep our secret for our application, because every application depends on some secret. Even if it's a third-party API that you are going to use, it is going to be a secret. Okay, so we'll go back to our code and then we will create a .env file. It's always created .env. It's always being created inside the root folder of the application. Okay, and what we are going to do here is to just give, first of all, whenever you are building an application, you need a port. So the port is going to be, can be anything, it can be anything 6002. Okay, any port number that you want. So we say 6002 or whatever ports that we want, but in order to be in sync, I will, for now let's leave it. I'll show you. And then inside our app, we need to do some configuration. So we need to do some configuration. So we need to import. We don't have a name export for .env, so it needs to be .env. Now const app equals to express instance. Okay, so now we have the express instance. Now what do we need to do? We need to configure the .env. .env is configured by .env.config. So now when you make this, now you have configured .env. Now get the port. So const port equals to process. Now you can use process.env.port. Don't give it all 5,000 or anything. Okay, when you have it, it should be there. Now how do you start your application? So if you go back to ChatGPT, it already has it for you. So let's minimize the code, and then we can just copy in this code. Sorry about that. We can just copy in this code and then we'll put it there. So we can just copy this code, we put it there. So what are we going to do? We are just going to use so that we can pass data. We can pass data from our client side. Okay, so that's why we are using the express.json. We can pass the JSON data. That's all. So if you want XML data, you have to do that. Now we need to listen our app. So whenever you are creating an application, first of all, let me show you. Whenever you create an application, you get a port and then you need to listen. So to listen, the app is going to be app.use app.use. So I believe it's no app.listen. To listen is app.listen. App.listen and then the port. So it's going to take this variable and a callback function. Okay, so when you see this, it's called a callback function. This is not a programming course, but just you get a little bit. So now all we need to do is to console.log Atlas API is running on this specific port. That's it. So inside the API, run yarn dev. Okay, so we don't have yarn. Npm run dev. Nice one. So now you can see Atlas API is running on port 6002. That's all. So whatever environment variable we kept here, that's all we used. Okay, that is very good for us. Very good. Clap for yourself. You have done so well coming this far. Wow, I'm very proud of you. So you've built your first API, but then an API is not an API until you have some endpoint. So I will just grab some endpoints and then explain it to you here. So we have to get the first endpoint. So you get some endpoint for us. So this is going to be good. So inside our code, remember app.listen is always the last one. Okay, yes, that is beautiful error. Okay, so that is going to be a very beautiful error. So everything is down there, correct, and then you app.get. Good job. So app.get, the first one is going to be our health path. So it's going to be our health path, and then inside that we are just going to give this response code. Okay, we are going to return this response code. That's it. Then the next one, you get it here. Yeah, because we did not import these ones from request. express, and then the response. Import the response as well. Yeah, that's it. So whenever we will visit this route, we need to hit if okay, then we if everything is okay, we will send a status code 200, and then the status is going to be okay, correct? And then the next one, if we visit this route and if everything is okay, then we will see that our application is ready. Okay, so let's check also. We don't need the version. And now when we visit our root folder, when we visit our root path, then we just need to say Atlas API is also whatever, it's running. You can give it whatever you want. So we return the status code. Nice one. So again, everything is running. Open a new new folder. So once we get that running, let's test it. So we will just curl it. So let's test it now. Open a new what do you call it, terminal inside the API folder. Then we will say curl http ://localhost. It's also 127.0.0.0. So localhost is 0.0.0.1 or something like this, yeah, if I remember correctly. But if you say localhost, it will work because the DNS is configured. So localhost, and then port. Which port is our application running on? 6002. Cannot get this route, error. So something went wrong. Clear the screen. 6002. Okay, so something went wrong here. We should be able to get this JSON message instead of something went wrong here. Let's debug this. Okay, let's debug this together. I'll copy this one and then give it to ChatGPT. Let's fix it ASAP. Because we cannot get, because it says that path is not configured, but it is configured. It is configured, so it can't tell us it's not configured. It is configured. So I'll copy this one and also give it to it so it has more context. Here is my index file. Okay. So we need to stop and run the server. You know what? Let me show you one more trick, because I don't like when it does this. Let's install another one. npm -i nodemon. Install nodemon. Okay, that is going to help us. What is that? Okay, did nodemon stop working? Let's install nodemon, because nodemon is going to help us install and start our application. So it's going to help us start and restart our web server for the development side. Okay, so we don't have to face that problem again. So we are now installing it, so we have to install it as a dependency. So yes, now go back to the package.json file. Okay, you wait, we get an error again, but
Yeah, this can be tedious. But either way, what I wanted to show you, instead of TS node, we will just use node 1. That's it. And then you will go to stop this server, clear the screen. Yeah, npm run dev. Now it's running our application. Good job. So imported service cannot be found, but it should be. Quick fix. We do not need to use require. I don't know why you want to try that, but no way, my friend. Let's fix this one again, because I really don't like when we get errors like this. It's from the TS node, because we shouldn't have installed that one. Oh god. So yeah, so when you are building, this is some of the challenges that you face behind, so you need to be conversant solving all these ones. Okay, so oh, what the hell is happening? So you will get this error message, and then we'll go to AI. So let's minimize this one. You know what, so now we'll do it from codecs. So errors, because we already installed everything. So we check it for us, and then we'll see. So let's see what is pinned out now. So okay. So we need to reinstall it. But we already did install .env, so it shouldn't be like that. And then we need to also install it types. Okay, now we installed it, so it worked. So we just needed to install it again. Oh Jesus, this can mess up sometimes. Yes, but then that's it. So yarn, I like yarn, but we are using npm, so npm run dev. So we are importing request. Again, we have so this type checking is also wrong here, but hey, we can remove it and solve the problem. But I need it, because you need to type check everything. When you are using TypeScript, we need to ensure that we are type checking everything. Okay, so it's fix it for us. So okay, so the error happened because of that type model, but your TypeScript config is CommonJS. Okay, yeah, that is very tricky, because that is one thing you always forget. So yes, so you see, if I go back, you can see we have this type model here. Exactly, it should always be CommonJS. Okay, if you change it to CommonJS, everything should sync properly. Nice one. So that's it. Now let's do our curl again. Curl, and then it says cannot. Now give me the curl command to test. So let's test it. Nice. So service is okay. Nice one. Everything is okay now. So I want to test the main path. So we would test the main path. Cannot get. That is so weird. It should be working. We don't have that one. That is why we don't have the main path. So let's get one for the main path. So app.get. That's why it wasn't coming. So app.get, and then we will say the path routes request, and then the response, welcome to Atlas API. So I'll clear the screen. Nice one. So now we have welcome to Atlas API in a JSON format. That's all we needed. So yes, welcome to your API crash course. This was not what I intended to show, but again, we have built an API which we are going to use for testing purposes. Okay, so now we have our API done. The main aspect we need is also the Docker. We need the Docker file. We need to create a Docker file. Okay, not that one. So now we need to create a Docker file. How do we do that? To create a Docker file, so whenever you are building an application these days, you are not going to deploy on a virtual machine. So you need to package your application into a Docker container, and then you can deploy it onto any container orchestrator platform that you know. Okay, so we know Kubernetes, and that's what we are going to use because we have already deployed Kubernetes. So that's what we are going to do. So once we do that, we would get the Docker file, and then we would go through it here. So inside the root folder for your backend, whichever name you give it, it's going to be Docker file. Yes, now you can put some Docker code here. Nice one. Would like to access app from other directly? Not really. Don't do that. Now save this one. So again, we are going to use the image. So whenever you are going to write a Docker file, you need to know which image you are going to use. So you are going to use from to list the image that we are going to use, and then the working directory that our application is going to be in. So we create within the container, we create a folder within that we put all our code inside. Okay, so you can change the name to anything that you want. And then once we do that, then we have to install the dependencies. So we first of all copy the package.json, and then run this command to just install it. So npm ci to install them. If it is Maven or if it is Python or anything, you just need to know the commands to also install them. That's all. Now build the application. So from dev side, we are going to run as a build. So we are building in stages. Okay, so we will copy the ts config and then also the source folder into the folder that we have created in our container, which is the app. Now we also run the build from there as well. Now we will install package dependencies only. We will run this command, and then over here again, this is the final stage. We are going to use this node image because we run into, if you don't have this part, you are going to run into trivially breaking your CI/CD pipeline because it finds critical error in the node package version, okay, for the Docker container. So we need to use this image instead, and then we will set the environment to production. Now we will also copy the prod dependencies. So we need the node modules. We'll copy that from the app into this node folder, and then we will again build the app from dist. So we copy the one from the dist, and then we will also set the port. So which port are we exposing? So let's say we have this port. Let's change our port here. This is also one reason why you should use the environment variables, because in later, if you want to change your variables, you just don't go to the code base to change everything. You just change it in one file. That's all. And then we will just give a label here, and then a description, and then that will be it for now. So how do we run our application? So it's just going to be this index.js. That's all. Then our application will be running. So we have our Docker file ready. Nice. We will save it, and then we will move on. Okay, so we can do one for the front end for now, but I still think maybe we should do it. Yeah,